Okay, in this video we're talking about angle in a semicircle theorem. But just before looking at it, make sure you're familiar with the circle terminology and proof, because all this stuff's really important. The other stuff that can come up a lot are the angle theorems and properties of triangles that you might have seen in previous years. If you're not super familiar with them, don't worry, because we'll go over those as we come to them. So here's the theorem here, and it basically means that if you've got like a diameter of a circle and you draw a line out to the circumference like that, that will be a right angle. So you've got a converse here. So if you've got a triangle like this, which is right angled, and you take the very middle of the hypotenuse, you can draw like a circle around that, and it'll all work out like a circle should. The other converse is if you've got a circle and you have a situation like this where that one is a right angle, you can guarantee that this thing here is the diameter of the circle, like it goes straight through the middle. So those two are good to know as well. So question 1, what is this angle in the circle below? Well, that is 90 degrees by angle in a semicircle theorem. We should probably say that is theta equals 90 degrees. Next, we've got the points ABC are on the circumference. Calculate the size of the angle BCA. Now, the angle BCA, what they're talking about is the angle which starts at B, goes through to C, and goes out to A. So they're actually talking about that angle there, which is theta. Just good to know what angle we're actually looking for here. So we can't calculate it directly, but we can make our way there. So I can tell you the angle ABC has to be 90 degrees, again, by angle in a semicircle. So that's a direct application of our theorem, and it makes that angle there 90 degrees. The other thing you'll use quite a lot is the sum of angles in a triangle. When you add up all the angles in a triangle, they should give you 180 degrees. So let's apply that. 53 plus 90 plus our mystery angle theta all has to add up to 180 by sum of angles in a triangle. Now, it is in a triangle, but we should be specific about which triangle we're talking about. This is the triangle that has the points A, B, and C on it. So this is triangle ABC. Now, it probably looks like overkill here, but when you have diagrams that have multiple triangles in them, it's really important to talk about which triangle you're referring to. So let's simplify this down a bit. 53 plus 90 is 143. Plus theta equals 180. Now you can probably see right now the answer is 37, but let's work it out formally. So we could take 143 from both sides. And what you're left with is theta equals 180, take 143, or in other words, 37 degrees. Okay, so that's fantastic, but we haven't actually answered the question. They asked for the angle BCA. So we've got to give them the angle. BCA equals 37 degrees. Okay, next one. In the picture below, AC is the diameter of the circle, and then we have these angles x and 2x. Find x. So immediately we're going to apply our theorem. Angle ABC equals 90 degrees by angle in semicircle. Therefore, x plus 2x plus 90 equals 180. And that's basically the sum of angles in this triangle we have. So by sum of angles in triangle ABC. So now we know they all have to add up to 180. Let's use that to figure out what x is. So 3x plus 90 equals 180. That's just simplifying the left-hand side. X and 2x give you 3x. Then we want to take 90 from both sides, and you're going to get 3x equals 90. Then you want to divide both sides by 3, and you're going to get x equals 30. All right, so let's step out and make sure this is accurate. If that's the case, then x will be 30, 2x will be 60, and then that angle there we already said before was 90. 30 plus 60 plus 90 does indeed give you 180 degrees in your triangle. Yeah, so that'll be all the bits and pieces that we'll do for this theorem. There are many more applications which we'll explore in the future questions. Now, I'm going to stop right here and say I have intentionally made a mistake in one of these 3 questions. If you're feeling very confident, you can pause the video and try and see what it is. If you're not going to do that, I'm going to tell you what the mistake is right now. Back up in question 1. we said theta equals 90 by angle in a semicircle, and that's not entirely accurate because angle in a semicircle theorem requires this line here, AB, to be the diameter of a circle. And nowhere in this question did I tell you that this line here was the diameter of the circle. So there's a couple ways you could do that. You could do like a dot there to show the center, or if this was the letters A and B, the question could have said AB is the diameter. So this is the thing in maths. You have to like be a bit of a smart aleck and not assume anything. So if I don't tell you something is the diameter, then you can't really assume that it's the diameter, and that's something you've got to be really careful of in maths.